This is the Burj Khalifa, the tallest building on Earth.
The world's tallest skyscraper.
The Burj doesn't just break the world's tallest building record, it completely shatters it.
It has 160 floors and is twice as high as the Empire State Building.
Taipei 101 could stand beside it with the Eiffel Tower perched on top and still only just match the height of this one.
Rising 828 metres into the sky, nothing else has ever really come close to topping it. But that was all supposed to change. Enter Jeddah Tower. At a staggering 1,000 metres, Saudi Arabia's $1.2 billion megatall skyscraper was due to become the first ever kilometre-high building in 2020. A tower that would finally overtake the Burj Khalifa and help position Jeddah as a global city on par with Dubai. Then things took a turn. Today, the building stands unfinished and abandoned 300 metres in the air. And after years of political crackdowns and a global pandemic, it remains unclear if Jeddah Tower can ever rise to its full height. Even if construction works do start up again, it'll take a massive feat of engineering to complete.
There are no building codes that prepare you for it, over a kilometre tall. This building had never been done.
With over $1 billion, and to a large extent the country's reputation riding on this tower, all eyes are on Jeddah to see if it can ever complete the world's tallest building. Now, like any skyscraper, the taller it is, the more attention it tends to get.
Jeddah Tower, soon to be the tallest building in the world.
Saudi Arabia is making a major push to diversify their economy.
Back in 2011, billionaire investor Al-Walid bin Talal had set his sights on creating a centrepiece for Jeddah Economic City. His bold plan for a skyscraper in, you guessed it, Jeddah, would feature 167 stories of homes, offices and hotels. At a kilometre tall, it would rise well above the 600-metre threshold for classification in the mega-tall skyscraper category, and would essentially try to make Jeddah the Dubai of Saudi Arabia. It's important to draw a distinction between this and the other huge projects that Saudi Arabia has recently announced, particularly around NEOM. They're led by its public investment fund, which is a state-driven sovereign wealth fund seeking to diversify the Saudi economy away from oil. Jeddah Tower is a private development, albeit one that started out with plenty of backing from many in the state. Now, to build something a kilometre tall, you need an architect with a strong resume. Enter Adrian Smith. If his name sounds familiar to you, it's because he's the guy who designed the Burj Khalifa. One of the biggest challenges with creating skyscrapers this high is the extreme lateral wind loads they face. The taller a building is, the greater its tendency to want to sway towards its top, and that's something engineers must address to ensure safety and comfort. To reduce movement, some super tools like Taipei 101 or 432 Park Avenue used massive weighted devices called tuned mass dampers near their summits that counteract swaying motion, but these can take up a lot of valuable floor space. For Jeddah Tower, Smith took another route, one that lies in the most fundamental part of the building design itself. Like the Burj Khalifa, the Jeddah Tower plans to use a buttressed core to reach its megatall height. Unlike most skyscrapers that have 4 external walls, this approach sees a hexagonal core reinforced with 3 Y-shaped walls. And that really does work. We use software from today's video sponsor SimScale to model how wind forces could flow around the Jeddah Tower's enormous form.
It's like the analogous to the 3-legged stool.
John Setra wasn't involved in Jeddah Tower, but he certainly knows a thing or two about the design of extremely tall buildings.
It's a very, very efficient system. The triangle works in ways to deflect the forces from 2 sides. It doesn't necessarily have the same effect as, let's say, a square where, there's a broad side on the square or a rectangle, and those forces are then deflected to the other three sides. The triangle actually acts as an automatic deflector.
The Jeddah Tower would also dramatically taper towards its peak, further reinforcing its resistance to strong winds and making it more aerodynamic than a four-walled straight-up profile. That really matters because winds get stronger the taller you go, and on this site, and with a building of this height, there aren't any other buildings or structures around to break up the airflow. On the 157th floor would be the tower's crowning feature, a jaw-dropping open-air observation deck that would easily become the highest viewing platform in the world. With that design finalised, building works first began back in 2013. Now, as we all know, one of the first steps of construction is also the most important: foundations. And to support something this tall, engineers needed to use a lot of concrete. First 270 piles were drilled 105 metres into the ground. Then a giant 5-metre thick concrete slab was placed on top. That would become the base, distributing the weight of all 1,000 metres of skyscraper set to rise above it. Next, the core was constructed, allowing the tower to steadily rise around it. Concrete was poured using a jump form system. That's a type of climbing formwork that rises with the core structure, allowing builders to work safely and with considerable efficiency inside. Mehdi Jalarian worked on some of the operational and technical systems within the building.
As far as the building configuration itself, what we did, the challenge that we overcome, we thought about it as being 20 to 40-story buildings and stacked on top of one another. So we broke it down into smaller pieces to be able to manage it.
In 2015, 2 years after construction began, the project secured $1.2 billion in funding from a Saudi bank and real estate venture. By 2017, Jeddah Tower had risen 63 stories above the desert, around a third of its final height. Despite some bumps in the road and minor delays, it looked as if the world would soon be getting its next tallest building.
Remarkable times in Saudi Arabia.
11 princes, 4 sitting ministers and dozens of former ministers have been arrested.
Among those arrested is the billionaire Al-Walid bin Talal, who is one of Saudi Arabia's most known business tycoons.
Things took a turn. When Mohammed bin Salman became Crown Prince of Saudi Arabia, he began an anti-corruption purge. 2 people caught up in the events included Jeddah Tower's key backers, businessman Prince Al-Walid and Bakir bin Laden, chairman of the tower's construction company, Bin Laden Group. That all caused work on Jeddah Tower to briefly stall. The project's backers were eventually released and work briefly restarted, but then there were labour issues with the contractor that further complicated matters, stalling it again. Just as construction was about to restart in 2020, the pandemic hit and works halted. It appears that ever since then, the tower has sat empty and incomplete. Yet, take a look at the official website, and the homepage still says it's happening. Jeddah Tower was going to be a challenge for engineers on a good day. Throw in these considerable political and logistical issues, and it's perhaps little wonder that things have seemingly ground to a halt. So we've seen what it's supposed to look like, but even if everything restarted, is it actually even possible to build this tall? Well, the truth is, we'll never know unless it's actually achieved in physical steel and concrete. What we can say is that engineers were pretty certain they could do it and built the core to almost the same height as New York's Chrysler Building before things got stopped. They worked from the established principles paved out by other tall buildings, and most notably the Burj Khalifa. They modelled, tested and simulated their designs in a wind tunnel and brought them to life in virtual software before even putting a spade in the ground or attempting to pour concrete above the clouds. The building's aerodynamic performance and ability to manage lateral wind loads was put to the test in a wind tunnel and then modelled in software similar to that produced by today's video sponsor SimScale. It allows engineers to test how different profiles and designs will perform under a range of conditions. All tall buildings have to manage wind loads, and as we said, it gets harder the higher you go. When strong winds move around structures, areas of lower speed air, also known as separation vortices, emerge on their opposite side, creating suction forces that pull at the buildings, putting them at risk of swaying back and forth. Tapering a building as it rises helps to break up the uniformity that causes this. We ran a model of Jeddah Tower through SimScale software to show you just how effectively this works. We also created a simulation showing how wind forces could influence the surrounding area at street level, both with and without the skyscraper. You can see the completed tower would be likely to produce stronger gusts on the ground near the base, so designers will need to work to minimise that and protect pedestrians. SimScale is a powerful cloud-based engineering and simulation platform that enables everyone to create high-fidelity simulation models for building physics, urban design, and sustainability. You can model everything from wind conditions to thermal performance, indoor air quality, and thermal comfort. By running these virtual tests early in the design process, teams can solve problems before construction starts, saving time and money. And for Jeddah Tower, time is money the longer construction is stalled. To take this concrete core in the desert and turn it into the full-height occupied building will mean running tests to understand the strength and rigidity of the existing structure before recommencing construction on top of it. The building's structural lifespan calculations are thrown off by part of it being 6 years older than the rest. Once the remainder of the structure goes up, an advanced cladding system needs to follow close behind. Mechanical systems that can withstand extreme conditions 1,000 metres in the sky then need to be designed and installed. And it'll need one of the tallest elevators ever built. Now, historically, skyscrapers this tall have required people to change elevators on the way up. That's because after a certain point, around 500 metres, the weight of the steel ropes used to lift them becomes too much. But innovations like Ultra Rope by Kony that we mentioned in a recent video replace those steel ropes with a carbon fibre material that's 7 times lighter and more durable. It means an elevator can travel up to 1 kilometre into the sky, and the B1M understands that Kony's system is specified to be installed at the Jeddah Tower should the building proceed. As you might be gathering, the whole extreme height thing really does make this project tricky. Despite that, some designers are turning it to their benefit.
At those upper elevations, you have actually higher intensity of solar. For example, the top of the building has a spire, which is the architectural silo. We had to build an environment where we could control the temperature, so the concrete is not expanding and contracting and in turn would crack. We utilize the temperature variation to create a stack effect inside the silo to be able to ventilate it properly. So it doesn't really use any energy. It's self-ventilated, but it's very controlled.
But the Jeddah Tower's location in the desert brings more than just intense heat to the table and creates a huge maintenance requirement.
The sandstorms it's abrasive, so you can imagine that that's very fine sand swirling around the building, and you want to have very durable coatings on the building that will not literally be sanded away. And that also then affects the cleanliness of the building. In the Middle East, they use many systems that don't require a human being to be on the scaffolding, and it's automatic.
Now, building something as bold as the world's tallest building will bring you headlines and some jealousy. You might recall plans for Dubai Creek Tower, a scheme announced by the UAE to bring the title of world's tallest structure back to the country that started work and then paused again after Jeddah Tower hit the buffers. Its foundations remain sitting there, kind of like a quiet warning to Jeddah should it ever start up again. Despite the long pause, Mehdi thinks things could start to move soon.
There is a lot of talk right now and planning to restart. They have built the utilities and roadways at the site. Obviously, it's been stopped for a while, and there are things that need to be rethought for the process. So now I think we're in a much better position.
While it may still be possible to turn this super tall stump into the world's tallest building, right now the challenges of funding, politics and extreme engineering all appear equally daunting, collectively putting a heavy block on progress. If the world's first kilometre-high skyscraper ever rises from these sands, it'll be both record-breaking and remarkable in many ways. This video is made possible by SimScale. You can learn more about that at the link below. There's also the chance to dive deeper on Jeddah Tower and the other topics on our channel over on the World's Best Construction Podcast, available right now wherever you get your podcasts. And as always, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.